We will continue now. We are going to extract the output characteristic cores of this transistor, and for that we will need to sweep VGS and VDS. Now it is possible to do this with the ADL, but we are going to use a little bit more advanced tool. We're going to use the ADA XL GXL because it gives us a much better tools for doing sweeps. So when we click it, it appears the following dialog. We just have to click OK. Okay, so we created the view. We can see that in our library it has just created the ADXL view, and yeah, this is a little bit more advanced tool. It is not so different than the IDE, and actually we have almost the same interface for many of the things that we're going to do. But it will allow us to do much easier handling of corners, Monte Carlo, and different tests at the same time. Here we have two tabs. One it is for the schematic, so we have the schematic view, and then we have another tab for the simulation setup and results. So we're going to make this a little bit bigger. And then we can open the test here and then click on to add test. And then it appears the following dialog. We just click OK. And then we have exactly the same view that we had before. Now, in reality, we're just going to use this view to set up things. We can, in principle, run simulations from here, but it is not recommended. The place to run simulations in ADXL, it is here. It is the button here on the top. So we do the same things that we did before. Variable, copy from cell view, and then we have here the variables that we can change. So we are going to give a set default values, for instance 180 nanometer, 1 finger, 1.0 volt, VGS 0.4 volt, and 80 micrometer width. Then I'm going to click here. We're going to have exactly the same setup. DC operating point, and then we are done for the moment. Okay, I close it, and then look what happened here. It created this test. If I open this test, we have different options, and I can actually click these ones and then do the same things that I used to do before in the ADE. I'm going to run the simulation, and then it is creating netlist automatically. Run the simulation. It appears a log here say that the simulation was successful, and then if I right click here in the results, somewhere here I have a bunch of information that I can use. I can, for instance, go to do the annotation that we did before, annotate the DC voltages, and then it will go to the schematic and get my circuit annotated. I can then go back and do the same for the annotate the DC operating points. So I will have annotated the currents and other bunch of information that is available. Now, what we're going to do now is we're going to configure a sweep, and for that I can double click here in analysis, DC, and then I'm going to sweep a variable. The variable that I want to sweep, we can select here from the list of variables in my schematic, and then I'm going to sweep the gate to source voltage. We're going to start not from 0, because we're going to start from 1 milli, and then we're going to stop in 1.8 volts. And then I'm going to run a linear with a step size, let's say 40 millivolt. We apply, and then enter, and then we run the simulation. And then it's simulated without errors, but we don't have anything to plot because we have not configured any output to plot. So that is what we're going to do now. We go to output, and then we can go to here to select expressions. Actually, we can do exactly as we do with the ADE. We just double click the name of the test, and then it will open the ADE. Now we are going to configure these results, the outputs. I go to output to be plotted and select on design. And then it opens automatically the schematic, and I'm going to do a click on the drain terminal. Put the drain terminal, and I see that it is updated here. Actually, we can make this a little bit smaller. And when it updated my output list here, it also updates with a circle here telling me that I have selected the current entering in this node. Okay, so I close it, and then I check here again, and then now it has created this signal MOD. So this one was created by mistake. I'm just going to remove it. So now we have one signal that is going to be plotted. I can actually click it to save also if I want. It will save it in a file. But for now, we're just going to click it here, and and then we get it ready for plotting. We have a simulation that was successful. It simulated all the gate voltage that I wanted. So we click here, and then the Viva will open and show the drain curve versus VGS. Okay, so it is as expected. Now it might be that we want to plot this curve for different VDS voltages, which means that we need to do a double sweep, and Cadence is not very good doing double sweeps, but the ADXL has a very nice feature for doing that, and it works like this. So we open the global variables here, and instead of using VDS 1.0 we are going to change this. So we delete this one and then we click it here. Here we click in add specification, and then we are going to use from to. So we are going to put from, and then we put a value, for instance, from 1 milli. I don't want to put 0 because if there is 0 amps current, I will not be able to do logarithms later. So I will start from a value that is different than 0. But I can put 0 if I want. And then I will stop in 1.8 volts, and then I want to use the cuts here because or we can use just linear for a second for the first time. It was linear, and then let's use like 20 millis or 50 millivolts VDS. Okay. And then it automatically creates me this configuration for VDS. Now I run it. And it is a sweep of 36 VDS points here, and it's going to do it one by one. Now if I want to speed this simulation, what I can do is I can go to options, job setup, and then I can increase the number of cores that I will use during simulation. For instance, I can put 8 cores. Apply, okay. And now it will start using the 8 cores, and then it's going to be much more faster. Okay, some point it is finished, then I can plot all. And then I have the curves for the drain current versus VGS for each value of drain. So we can see, we can select the curve and etc. etc. Okay, here I can just hide all. I can just select one by one. So there is a number of things I can do. Nice thing, for instance, is that I want to pick up a particular value, I can send it to the calculator. So we have this value of the current, and then I can do some processing here. Probably the first thing that I want to do is to test if it is actually working. So I can open it here. Okay, and one thing that I might want to do, for instance, is to use some function here. For instance, if I derivate the current, I will get the transconductance. So I can use the derivative here, and then it is already there. Save it here, and then I evaluate it. Then whenever I evaluate it, I get the transconductance, the value of the transconductance. So as I said before, there are many functions here that are specialized for analog design, and so that we can use. Now in this case we have we have used sweep for the VGS, but probably we want to change the order of the sweep, and for that there are several options. One of the options is that we just change, we duplicate this test. So I'm going to, actually I'm going to rename this one. I'm going to rename this test. You can just come here with one click and then we put it VGS sweep. Then you cannot have spaces. We have VGS sweep. Then I'm just going to copy this one, create a test copy. I'm going to change this one to VGS sweep, and then I'm going to deactivate this one because I just not interested to run both at the same time. And then I'm going to edit this one. The analysis, the DC analysis, and then I just changed the variable to VDS, and then I keep the same step size. That's okay. Apply. Okay. Now I have to change the other the other variable. So what I can do it is copy paste this one here, and then I can, for instance, bring this one to 1. This one anyway will be swept here. Now I am ready, and then I just send the simulator. It's done. Send it to plot. And then I got the output curves for this transistor. Now probably I want to see the weak inversion. I might want to do like this, and then we have the currents in weak inversion, and then going to moderate and strong inversion here on the top. So I bring it back from logarithmic to linear scale, and yeah, this is how I will probably set up a DC sweep. And again, I mean, there are many other things that we can do here, but this is the basic setup for the ADXL. So we can copy test, activate, deactivate test, change the global variables. We even have the chance to use the design variables as local here, and probably that would have been better. Instead of deactivating this one, changing this one, we can change it here. So there are many options that could have been done. Okay, so for now we are done with biasing of the transistor with the double sweeps.